This video presents the Stereoscopic Rendering option feature of the R19 CineRender engine, built into ARCHICAD, developed by Maxon. Stereoscopic renderings are two-dimensional images that contain certain additional information about the 3D properties of the displayed content. To be able to enjoy such 3D characteristics, it is necessary to have a 3D viewer device. If we enter this to Google search, we'll see various devices developed to explore 3D or stereoscopic images. Let's see how to create stereoscopic renderings in ARCHICAD using its built-in CineRender engine. Let's display the photo rendering settings and enable the detailed settings option. Please notice the Use Stereo Renderings panel. Please remember, if this panel is not enabled, the resulting rendering will be two-dimensional. But, as long as this panel is enabled, all created renderings will be stereoscopic. For stereoscopic results, every image must be rendered twice, a slightly different image for the two eyes. This means that 3D renderings take twice as much time as conventional 2D renderings. Let's see the stereo camera option. Here we can define the characteristics of the two rendered images. There are various symmetrical modes to choose from. These define the position of the two cameras compared to the original camera position. Using the eye separation value, we can define the exact distance between the eyes. The default value is 65 millimeters because this is the typical distance of the center of the human eyes. If we would like to create a stereoscopic render of a cityscape, or about objects further away, this value might need to be slightly increased. Creating stereoscopic renders of objects up close, the eye separation value may be decreased. The placement defines the relations of the camera axes. The off-axis option typically produces good results. The zero parallax defines the distance between the camera and the point where the two images overlap. In other words, this value defines the focal point of the camera. 10,000 millimeters is an appropriate value for most cases. If this distance is too small or too large, it will not be comfortable to view the final stereoscopic render. The default settings of the stereo camera panel are appropriate for most of the cases. That is, symmetrical mode, 65 mm eye separation value, and 10,000 mm zero parallax value. Let's display the stereo rendering options panel. Here we can adjust certain characteristics of the final rendered stereoscopic image. The most common rendering mode is called anaglyph. This produces separate blue and red images for the two eyes, and requires a stereo glass with blue and red filters. Here you can see some anaglyph stereo glasses made of paper. This rendering mode produces a single rendered image with two different colors. The main disadvantage of this mode is that the colors of the image will be slightly distorted. For this reason, it is recommended to select the gray anaglyph method. This will produce a monochrome stereoscopic image. Let's select this option and render the scene. The CineRender engine will render the scene twice. The first rendered image produces an ordinary result. The second rendering sequence produces slight differences compared to the first. At the end of the rendering process, a monochrome black and white image is displayed, with some red and green tones along the edges of the elements. Looking at this image with anaglyph stereo glasses will produce a stereoscopic view of the scene. Let's review the additional rendering options here. It is possible to select individual channels to render the channels separately and then merge them using another application. It is also possible to render a single channel only. All the previously discussed options can be adjusted for a single channel render. Let's switch back to merged stereoscopic image. Please note that, besides anaglyph, the side-by-side and interlaced rendering modes are also available. The side-by-side mode is recommended for printed stereoscopic images using full color range. In this case, both images are visible and placed next to each other. The interlaced mode produces a stereoscopic image that can be displayed on 3D televisions. In this case, the 3D information is stored at pixel level. Let's render a stereoscopic image of this scene using this mode. The engine renders the scene twice, just like before, Here's the final stereoscopic render using the interlaced mode. As you can see, the image looks a bit blurred without stereo glasses. Please note that the colors were not modified in this case. It is necessary to view this image with appropriate stereoscopic glasses. Let's use the side-by-side mode to render the scene. The engine will render the scene twice before displaying the final result. Please note that in this case, two separate images are displayed side by side. To be able to view the result, it is necessary to have the appropriate stereo glasses. Before starting to render a stereoscopic scene, it is important to know in advance the stereo glasses and publication method that will be used to view the image.